Hello, everyone. Today we are going to talk about 9.5 geometric sequences. Yesterday we talked about arithmetic sequences, which remember in an arithmetic sequence we add. So it'd be like 2, 5, 8, 11, dot, 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 where we add 3 each time. And we call D 3 because D is our common difference. So today we're going to talk about geometric sequence, which is a sequence which each term after the first is found by multiplying by the previous term by a constant called R, the common ratio. The common ratio can be found by dividing any term by its previous. So if we look at example 1, we're determining whether the sequence is arithmetic, geometric, or neither. So it's 21, 63, 189, 567. Hopefully I noticed right away that there's no way I can add something to 21 that I also add to 189 to get 567. So I know it's not arithmetic. So to figure out if it's geometric, I divide 63 by 21, 189 by 63, 567 by 189, and they all equal 3. So therefore it's a geometric, and the common ratio is 3. So for example 2, when I'm finding the next 3 items in the geometric sequence, I need to first find my common ratio. So I divide 405 by negative 1216. And I do that the same for all, and all of those equal negative 1/3. Therefore, my common ratio is negative 1/3. So to find the next 3, I multiply 45 by negative 1/3, negative 15 by negative 1/3. You should all have a negative sign in them. And 5 times negative 1/3. So the next 3 terms are negative 15, 5, and negative 5/3. So here we're going to identify if they are arithmetic or geometric or neither. So when I look at number 1, I can go from 1 to 2 by adding 1. But if I add 1 to 2, I don't get 4. So it's not arithmetic. So now I'm going to look for geometric. So if it's geometric, that means that 2 divided by 1 is equal to 4 divided by 2 is equal to 8 divided by 4. And yes, those are all 2. So it's geometric, and my common ratio is 2. So number 9, I go from 9 to 14, I add 5. 14 to 6, I subtract 8. So that's not arithmetic. If I check for geometric, it would be 14 over 9 and 6 over 14. Well, those clearly aren't equal, so it's neither. So I want you to pause and decide if 3 and 4 are arithmetic, geometric, or neither. So when I look at number 3, I say, well, I can subtract 1/3 to go from 2/3 to 1/3. But if I subtract 1/3 again, I would get 0, not 1/6. So now I look to see if it's geometric. So 1/3 divided by 2/3 equals 1/3, or 1/2, sorry. And 1/6 divided by 1/3 equals 1/2. So this is geometric, and my R equals 1/2. Number 4, to go from negative 2 to 5, I add 7. 5 to 12, I add 7. 12 to 19, I add 7. So that is arithmetic, and D equals 7. So on our next set, they're telling me they're geometric, and I'm asked to find the next 3. So I know they're geometric, so I really need to just figure out what my R value is. So to find my R value, I do negative 216 divided by 648. It's always the next one divided by the one before it. So when I simplify that on my calculator, I find out that R is negative 1/3. So then to find my next 3 terms, I do 72 times negative 1/3. And that gives me negative 24. I then do negative 24 times negative 1/3, which gives me 8. And then I do 8 times negative 1/3, which gives me negative 8/3. So the next three terms are negative 24, 8, and negative 8/3. So I want you to pause and do the next three and come back and check. So I forget to pause or unpause. So first thing I need to do on 6 is I need to find the r. So I divide the second term by the first, which gives me negative 1/5. I then multiply 1 times negative 1/5 to get negative 1/5. Negative 1/5 times negative 1/5 gives me 1/25. And then I do 1/25 times negative 1/5 gets me negative 1 over 125. Number 7, again, I find my r by dividing 1/2 by 1/16, which is 8. So I multiply 4 by 8, 32. 32 times 8, 256. 256 times 8, 2048. Again, for number 8, the first thing I do is I find my r. So I divide 36 by 72, which gives me 1/2. And then I multiply 18 by 1/2, 9. 9 times 1/2, 9/2. 9/2 times 1/2, 9/4. So in a geometric sequence and functions, the nth term of a geometric sequence with the first term a sub 1 and common ratio r is given by the following formula. This is a formula you must memorize. So there's a couple of mistakes in this first example typed out that you need to fix. So to write the equation of the nth term of the geometric sequence, 5, 20, 80, 320, the first term is 5, not 320. So a sub 1 equals 5. So now I need to find my common ratio. So I divide the second term by the first term, and that's the same for all of them. So r equals 4. So the common ratio is 4, so r equals 4, which gives me the formula a sub n equals 5 times 4 to the n minus 1. I cannot simplify that anymore. So then to find the seventh term, I substitute 7 for n into that. And so I first do 7 minus 1 gives me 6. Then exponents come first. So 4 to the 6th is 4,096. And then I multiply. So let's do number 9 together. Write an equation for the nth term of the geometric sequence. So first of all, a sub 1 equals negative 2. A sub 1 just means the first term. Now I need to find r. To find r, I do the second term divided by the first. So it's 10 divided by negative 2, which gives me negative 5. So my generic formula is a sub n equals a sub 1 times r to the n minus 1. I substitute. It's really, really important that since r is negative, it goes in parentheses to the n minus 1 power. So this is my equation. A sub n equals negative 2, parentheses negative 5 to the n minus 1 power. So now to find the 11th term, I replace all the n's with 11. So it's a sub 11 equals negative 2, parentheses negative 5, close parentheses to the 11 minus 1. So that's negative 2 to the negative 5 to the 10th power. I do my exponents first. So it's negative 2 times 9,776,000, or 765,000, 625. And that gives me my final answer of negative 19,531,250. So I want you to pause, and I want you to do the next three. Okay, so on number 10, again, a sub 1 is going to be 512. I find my r by dividing 128 by 5/12, 1/4. So my equation is a sub n equals 512 times 1/4 in parentheses to the n minus 1 power. They want the sixth term, so I substitute 6 for n. So it's 512 times 1/4 to the 6 minus 1 power. I subtract. So it's 512 times 1/4 to the 5th, which gives me 1/2. Number 11, my a sub 1 is 4/9. My r is 9 because 4 divided by 4/9 is 9. So then my equation is a sub n equals 4/9 times 9 to the n minus 1 power. A sub 8 equals 4/9 times 9 to the 8 minus 1 power, which gives me 2,125,764. And last but not least, number 12, again, a sub 1 is 6. To find r, I do negative 54 divided by 6 is negative 9. So a sub n equals 6 times negative 9 in parentheses to the n minus 1 power. I substitute 9 to find the ninth term, and my answer is 258,280,326. That's the end of our video. If you have any questions, please ask me to